So what we'll be doing is that we'll be creating a player here. We'll be fixing the camera positions. We'll be making the scripts for it, and um, we have a script pre-made, and I'll explain each code since due to time constraints, we won't be able to go through all the codes or write the code by ourselves. to your browser directly. So over there, um, you get this. Wait. Yeah, you'll get something called low poly FPS matte light. So I'm pretty sure Prakash must have shown this package in the last class. So just go ahead and download it. So over here, you'll find download and import. I've downloaded before, that's why it says re-download. Click on download and then click import. Sorry, you're supposed to import this. Okay, open this, and inside scenes, you'll find demo and overview. We'll be using demos. Okay, so this is the scene that you'll get. This is what we'll be working with. Right now, we'll create our player and we'll create the camera settings for that. So let's create a 3D object. Let's go with capsule. This will be our player. So this is how our player is gonna look like. So before we move on, we'll be needing a few layers. So we know that there is ground and there's a player as well. We'll create layers for that first. So okay, we've added the player. So under the player, we need we need something to keep track of its position. So we'll create an empty object and we'll name it orientation. So orientation, what it does is it's just that it keeps track of the position, the rotation, and the scale of this player. Okay. Yeah. And then under player, we'll create another empty. Let's call it the player cam. So this is basically just like orientation, but we'll be using this for our camera component. So let's create another empty object. This is a camera holder. And under this, we'll be creating camera. So this is the camera that's responsible. So what we'll do is that we attach this camera with the player so that when we move or when we rotate, it moves and rotates with the player. So under camera, let's create the movement script for a player. Okay. Uh, player. So I'll send a GitHub repository link. Using that, you can you can find the scripts here. Just go to assets and then you'll find the scripts here. So you can find the necessary links here. Over here, I'll be using the assets and I'll be copy pasting this code. I'll explain the code. We'll open the script. Okay. So we have to define the vertical and the horizontal movements. So we'll be defining a few functions here. We have to move speed. So Prakash taught you that public and float, public and private. So what with public, we can give our values in Unity, whereas for private, we'll be defining a value in the script itself. Another thing is that with public, we can access it from other scripts as well. So we defined these things: move speed, ground drag. We'll come to jump force and jump cooldown later. Uh, we have, yeah, the horizontal and the vertical input. Transform orientation. This is what we'll be using. Like we create another tab, right, in our hierarchy. So the orientation comes in there. Over here, this is we use the physics function here, and we give our position. Oh wait, this is for height. Sorry. Yeah, we give our horizontal and vertical using our mouse movements over here, and then we also give our sensitivity, which is responsible for the rotation. So I'll save this. Okay, so we get a few empty spaces here, like empty tabs, and we'll be adjusting. So if you see, we have speed, ground drag, jump force, etc. Those were the variables we had given here as public. Okay, so movement speed, I'll keep it at 7. Ground drag, maybe 3 to 4. Uh, jump force, 5.25. So if you guys remember, we defined a layer, right? So what we need this layer because when we attach a rigid body component to our player, so rigid body is what gives its mass or like the ability to collide. So right now it's just an empty object. For example, I'll show. Like there's no rigid body attached to this player right now. If I start, if I start, we'll just attach. our rigid body component. So this is what gives its mass, and this is where the gravity is manipulated. So under this orientation, you just give the position, just take and drag it here and ground. This is the thing which separates the player from this um, from the buildings or the walls. So we've given this demo, and this demo has all the walls and the buildings as well. So we'll be defining all of this under the layer as what is ground. And the player as what is player. So this is how we differentiate the player and the ground. So the thing is, in our code, we've defined some variables for jumping as well. So the main thing we check jumping is using a few booleans. So we check if it's grounded to see if it's, since we don't need double jumps, we'll see if it's grounded. Okay. So yeah, the input key we've given is space. So if we click on space and if we're ready to jump and grounded, then our player will jump. Okay, so that's what we've defined here. And for ground check, we use the physics component here. We use the vector down, which is just a um, raycast thing. So basically, what happens is that we define a vector here from the middle of our player, and then if it touches the ground, that means it's grounded. So we use this. Yeah. Now, what is player demo? Now we change our player height to maybe 2 to what is ground. Yeah. So for ground check, we need this layer. Yeah. So for a camera, we need our camera to follow this player. We have some extra cameras here, which is predefined in this asset package. We'll just delete it. Okay. We'll create a move camera script now. Okay. We have a public transform camera position. And then this is just for changing the camera position along with our player position. So over here, you can see that we've called a public variable here. So that means we'll be giving our orientation or the camera position. See, we have, yeah, so we have defined a player camera here, right? So we'll be assigning that. Don't forget to save your scripts. That's when the Unity makes changes accordingly. Yeah, so we have the camera position. We'll drag and give the player camera, which is just the orientation of the player. Okay, so the camera will move according to the orientation of our player. So now under camera, let's create another script. Okay. Yeah. So this is the camera that rotates with our player. So we have to define sensitivity first. We have sensitivity along the x direction and not x direction, x axis and y axis. And those are publicly defined as well. That means we can give a sensitivity values. So what we do here is that we have mouse x and mouse y, but we yeah, we use delta time and the sensitivity value um, to move our player according to our wish. Okay. Then we have this code so that we can constrain the angle of rotation of our player so that we don't need the player looking up or down below 90 degrees or like above 90 degrees. Yeah. So we'll save this. It's loading. So if you look, we've defined three public variables, and those three variables are here. I'll give a value of 350 and 350 here. And for orientation, I'll give this. So as of now, we've given a rigid body component to our player. We've defined its orientation and player cam, and we've given those variables or given those information over here. Yeah. Camera. So we'll just play and see how it goes. Yeah. So you can see as I move my mouse, I can, yeah. So we have a bit too much of ground drag. That's why it's sliding a lot more than it's supposed to. We'll just increase that ground drag, yeah, to maybe 6. And even the camera position, it's a bit too low. Let's just raise it up. Yeah. So this is what we'll get. We have to give the what is ground feature to BG as well, because that's the plane in this background. And if you want your player to jump, you have to make sure that you assign the what is ground feature to both BG and demo. So now as you can see, I can move and jump. You can increase the jump force as you require, increase the sensitivity along X and Y accordingly. Okay. Yeah. You'll just assign a color to this so that material. Let's give it. Now we'll create our enemy. Create 3D object. Let's create our, no, maybe not. Let's create it in the form of a cube. Yeah, so this is our enemy. Let's give it a color as well. Create material. Okay, so design. So we have a few scripts here. Yeah, we'll be using AI to control the movements of our enemy. So we'll be needing a nave mesh for this. Yeah. Before that, let's create a prefab for bullet as well. So let's use a sphere. This will be a bullet. So as you can see, it's a bit too big. Let's decrease the scale, maybe to 0.2. Yeah. Let's create a spawn point. So this is the point where we want our bullets to come from. Let's give it here. As for our bullets, let's create another material. This is our bullet. Okay, now we'll be adding a few more components to this. Let's add a nave mesh agent. And we'll be needing one more thing in our hierarchy, and that's nave mesh surface. Nave mesh surface. So some people won't be having the name mesh surface right now. So what we'll do is that we'll go to our Windows, we'll go to package manager, and search for AI navigation. Yeah. So this is what we need. We'll install. And this is what we'll be using to make our enemy navigate our player. Okay. Let's close this. So now if you go to Nave Mesh, see we have a lot more components now. We'll be using this. Okay, but before we move on to that, let's go back to our enemy. And we'll be needing an enemy AI script. I'm just gonna create a script called enemy. This is the script that we'll be using. I'll explain the script. Let's see how. Okay, so we have to define all of this.